Good day, everyone. Welcome back. We're looking at Lesson 5 today from Unit 6 in Math 10C. Unit 6, of course, is dealing with relations, equations, and graphs. This lesson is called Slope, and it can be found on page 16 of your unit handout. You will need a ruler today for much of the work we do. What are we doing today? We're going to define what slope is, and then we're going to be able to, at the end of the lesson, determine what the slope of a line is if we're given coordinates of points on the line or if we're just given a graph. You should, at the end of the lesson, know the difference between a positive and a negative slope, and also be able to explain what a slope of 0 means and what an undefined slope means. And along the way, we'll talk briefly about why a straight line has a constant slope. To begin with in this lesson, I'm going to be clicking through and not doing a lot of writing, so if I'm clicking a little too fast, then of course you can pause the video so that you can record any notes or solutions to examples that you need to. What the word slope is it's a word that's used in math to tell us how fast a line rises or falls from one point to another. When we are talking about a graph and we're going from one place on the graph to another in terms of a line, we always go from left to right. And this will not be the only time I mention this. It's always from left to right. So if I were to take a look at that line, that thick brownish line, when I look from left to right, the line gets further up. It's pointing upwards. So we would say that the line rises. In other words, if that were a hill and you were walking from left to right along that hill, you would be gaining elevation. So the line rises. On the other hand, if you were walking from left to right on this line or on this hill, the line falls. And what we do in high school math is we say that that is a rise that's negative. So the line on the left is rising in a positive way, and the line on the right has a negative rise, which means it's not actually rising, it's going down. Always from left to right, what's happening with this first line is the line goes up, and from left to right, what's happening with the second line is the line goes down. So what slope is often calculated using is this idea of what's called rise over run. And what rise is a vertical change, and what run is a horizontal change. So one way to calculate slope is to determine the vertical change and divide that by the horizontal change. The horizontal change is always to the right. It's always left to right. And for that reason, and you'll get used to this in a couple of examples right away, for that reason, the run, I'm telling you, you should always treat it as being a positive thing. If you treat the run as always being positive, your work in high school with what's called coordinate geometry, graphs in other words, if you always treat the run as positive because it's left to right, your job will be easier. The vertical change will be a positive number if the graph actually goes upwards, and it will be a negative number if the graph goes downwards when you're looking from left to right. A couple of other little details we need to get out of the way. We use the letter M to mean slope. That's just something you are going to have to get used to. And in math and science, and you'll see this a lot in physics, and you'll also see it in chemistry, that triangle, which is a Greek letter called delta, is what we use to mean change in something. What that means is when we look at a line drawn on a coordinate grid, then the rise is how much the value of y changes, and the run is how much the value of x changes from one point to another on the line. And that means I can either calculate slope using rise over run or change in y over change in x. Because delta y is really the change in y, which is the rise, and delta x is really the change in x, which is the run. So delta y is the rise, delta x is the run. Let's go through some examples here. To begin with, there's a warm-up, and it says plot the points -5, -2, and 3, 4 on the grid and determine the slope of the line that connects them. So first of all, a quick refresher here. Hopefully you know this. When you talk about the coordinates of a point, the first number is always the x-coordinate and the second number is the y-coordinate. So if I want to plot point P, I start at the origin and I go 5 to the left to get an x-coordinate of -5, and then I go 2 down to get a y-coordinate of -2. And that's where point P will be plotted. All right, let's plot point Q. Point Q is at 3, 4. That means I go from the origin 3 to the right because the x-coordinate is +3, and I go 4 up. Again, the first number is x, the second number is y, and I can plot that point, and you can take a ruler and connect those 2 points. Remember what I said, I'm not going to be waiting for you to write things down. I'm just going to be assuming that you're keeping up, and if you're not, you have to pause the video. So how are we going to determine the slope? Well, we're going to draw a triangle, and the triangle starts at point P, and I draw a line to the right, always from the point to the right. And then I draw a line up to Q, forming a right angle triangle. What I've actually done here is I've created a triangle that has a run, left to right, and a rise, which goes up. So the run is to the right, the rise is to the sky in this case. The run is always to the right. So what do we do with this? Well, we're asked to find the slope. I can look at the fact that the rise is 6 when I compare the bottom of the triangle's location, which is at -2 for y. It goes from -2 for y all the way up to +4. Well, that's a rise of 6. And when you look at the run, it goes from -5 for x to +3 for x. That's a run of 8. And that means that the slope, which is the rise over the run, is 6 divided by 8. And we would always want to express fractions in lowest terms, and that reduces down to 3/4. There's nothing wrong with you writing, I suppose, that the answer to this question is the slope is 0.75. Because 3 divided by 4 gives you 0.75. But you want to avoid having to use decimals all the time, because sometimes the decimals do not come out very friendly. Like if you had 15/17, that's not going to be a very friendly decimal. So that's warm-up 1A. B, what does that tell us about the line connecting P and Q? So the slope was 3/4. Don't forget that's rise over run. What that means is that the line goes up 3 units for every 4 units to the right. For every 4 units of run to the right, the line goes up 3. I want you to make a note that I could say for every 8 units to the right, the line goes up 6. Or I could say for every 12 units to the right, the line goes up 9. What's important is it's a ratio of 3/4 for rise over run. Warm-up number 2, we're going to get used to drawing some lines given slopes here. It's a skill that you need to know. So on the grid, we are going to draw and label 4 different lines with the following 4 different slopes. First one. First of all, when I say a slope is 3/2, I'm telling you the rise is 3 and the run is 2. So always go left to right. Always. I'm going to pick this as a starting point. You can pick any point you want here. It really doesn't matter because we're not asked to draw a specific line. We just want to draw a line with the proper slope. But I'm telling you that if you put your starting point about there, you will not clutter your diagram. So there's our starting point. The slope is 3 over 2, which means from that point, I go 2 to the right and 3 up. And I can put another point there. The run is 2, so I go 2 to the right, the rise is 3. From there, I can go over 2 and up 3 again, and I can draw the line. Once again, pause the video if you need to, but I'm moving on to the next slope, which is 2 over 5. Well, the bottom number is the run. The run is always to the right. The top number is the rise, which goes up. So I'm going to pick a point. I'm going to choose that particular point. You pick whatever point you want. From there, I'm going to go 5 to the right and 2 up, 5 to the right and 2 up, 5 to the right and 2 up, etc. And then I can draw with a ruler that line. So that is a slope of 2 over 5. If I take a look at the next one, on your handout it just says a slope of 2. So there's no denominator in the number 2 until we realize that 2 can be written as 2 over 1. So a slope of 2 is the same as a slope of 2 over 1. I'm going to go from some point, I'm going to go over 1 and up 2, over 1 and up 2, over 1 and up 2. And I didn't show you each of the individual steps here because by now you should be catching on. That line that I've drawn in black is a line with a slope of 2. And the last one in the second warm-up, 1/6 for a slope, means the rise is 1 and the run is 6. So I'm going to pick a point. I'm picking that green point near the bottom left of the grid. And from there I go 6 to the right and 1 up, 6 to the right and 1 up, and I continue that pattern, and then I draw the line. Very basic introduction in terms of how to draw a slope of a particular value using a line. I've already said this, but it's going to be important for the next part of the warm-up. A line that rises from left to right has a positive slope. This is a positive slope. It has a positive run and it has a positive rise. The slope is positive. If you have a line that falls from left to right, the slope is negative. Why? Because the run is positive. I go to the right from, I'll put an actual point on here so you can see it. I go from this point to the right, and then to get to this point, I have to go down. So the rise of this line is negative, and that gives us a negative slope. So warm-up 3. Well, let's draw some lines representative of negative slopes. When I have a slope of negative 2/3, everybody, the run is 3 and the rise is negative 2. Now, if you ever have a slope that's negative, imagine the negative being on the top of the fraction because the run is always positive. And you always draw the run first. Look, this number, negative 2/3, is how it would probably be typed on paper. It would be written as a negative and then you'd see the fraction 2/3. But that's equal to negative 2 divided by 3. And that's equal to 2 divided by negative 3. You can put that negative in front of the whole fraction, or you can put it on the bottom, but I'm saying put it on the top. And by the way, not just for slope, for anything algebraic, it's almost always easier to work with numbers if the top is negative and not the bottom and not the whole thing. So I'm picking a point here. All of these slopes are negative, which means all of the rises are negative. I'm going to go 3 to the right and 2 down, always going left to right. 3 to the right and 2 down, etc., etc., and you can draw your line. What does a slope of negative 1 over 5 mean? It means you pick a point, it doesn't matter where, I'm picking that green point, and I'm going to go 5 to the right and 1 down. 5 to the right and 1 down, and I repeat as many times as I want to, or care to, and I can draw the line. If I had a slope of -3, and on your handout that's all it says is -3, I can imagine that as being -3/1, which means the rise is -3 and the run is 1. I go 1 to the right and 3 down, 1 to the right and 3 down, and I repeat the process, and then I draw my line. -5/6, well, you take a point. I'm using that point in the top left corner of my grid, and I go 6 to the right and 5 down, and I can repeat it as many or as few times as I want to and draw the line. So far what we have learned or gotten used to is the idea that the slope is rise over run, the run is always to the right, and the rise is up if the slope is positive and down if the slope is negative. What I want to do in the next little part of this lesson is move away from having to draw lines on paper. But before we do that, I want to talk about horizontal lines and vertical lines. A horizontal line is a line that has a slope of 0. The slope of a horizontal line is 0. If I draw a horizontal line on this grid and I say, what's the slope? Well, there is no rise. So if the rise is 0, that means the slope is nothing. There is no slope. What about a vertical line? If I ask you for the slope of this line, it's an unanswerable question. Because really, there's no run, but there's an infinite rise. And for that reason, we say that vertical lines have a slope that is not defined. For you people who might move on to, say, calculus and start analyzing things in more detail, we could say that the slope of a vertical line is infinite. But we don't really want to get into that in Math 10. Warm-up number 4. So we're asked to plot point P, which is at -4, -5. So you're going to plot a point right here, and we can label it as P. And I'm going to ask you to be very careful about where you label things. I want you to try to replicate on your handout exactly what I'm doing here. That way you won't crowd yourself out later. We also have a point at Q, which is a 6, 1, which is here. And I'm not very good at drawing straight lines. I would rather the line I draw here is nice and straight, so I'm going to connect these with a tool. What are we asked to do? Find the slope of line PQ. So this is what you would do on paper, everyone. You would draw your triangle, starting at the point on the left and drawing left to right. I usually use a dotted line. And then you go up to point Q. This, of course, is the rise. And this, of course, is the run. So we can look at what the rise is. The rise is a total of, we can count the squares because each square is 1. It's a total of 6. When I look at the run, I can count the squares. Starting at P, I go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now we can find the slope. This is really not a difficult problem. The slope is the rise over the run, which is equal to 6 over 10. And we can certainly reduce that down to 3 over 5. Child's play. Very, very simple question. But the question becomes, is there a way that we could have found the slope without having to graph this? And the answer is yes. But let's answer these two questions first. How can you use the y coordinates of the 2 points to find the rise? Well, let's go back And let's look at the y-coordinate of point Q. The y-coordinate of point Q, well, let me just bring that back to where it is. The y-coordinate of point Q, Q was at 6, 1, and P was at -4, -5. The question is, how can we use these two things, these two y-coordinates, to get the rise of 6? And the answer is you can subtract them. If I take the y-coordinate of Q, and subtract the y-coordinate of P, what will that give me? It will give me 1 minus -5, and that gives me 6. So the rise, and this should make sense because rise is change in y, the rise is the y-coordinate of Q minus the y-coordinate of P. How can you use the x-coordinates to find the run? Well, when we take a look at this, this is asking how you can use this x-coordinate of 6 and this x-coordinate of -4 to get the run of 10. Well, we can subtract them. If I take the x-coordinate of Q and subtract the x-coordinate of P, that will give me 6 minus -4, and that gives me 10, which is the run. So when I subtract the y-coordinates, I get the rise, and when I subtract the x-coordinates, I get the run. So the run is the change in x, which is the x-coordinate of Q minus the x-coordinate of P. Well, what that really means, everybody, is if we put these ideas together, the slope of a line segment connecting 2 points can be found by taking the rise, which is y minus y, over the run, which is x minus x. You might have to think about that a little bit. When I take these two numbers and I subtract them, I'm going to get the rise of the line. When I take these two numbers and I subtract them, I'm going to get the run of the line. By the way, just so you know, and I taught for many years before I realized some students didn't know this, those numbers, 1s and 2s on all of our x's and y's, are not mathematical operations. They're not multiplications. All they are labels. x1 is the x-coordinate of the first point. y1 is the y-coordinate of the first point. And you'll see after we do a couple of examples, we don't even need to refer to the numbers. So we're going to use this formula. I'm going to write the formula down once in the middle of the screen for us. Slope is y2 minus y1 over x2 minus x1. Well, let's imagine that this is point 1, and this is the second point, point 2. I'm not using P and Q, I'm using P1 and P2. What y2 minus y1 means is I take -2, which is the y-coordinate of the second point, and I subtract 7, which is the y-coordinate of the first point. I don't want to make things too colorful here, but this is y2, this is y1, so I'm taking y2 minus y1. That's what's going on the top of the fraction. On the bottom, I'm going to have x2 minus x1. So the x-coordinate of the second point minus the x-coordinate of the first point. And now I simplify this. I end up with negative 9 on the top, and I end up with 2 on the bottom. So that's the slope, negative 9 over 2. Now, I want to pause here and show you how unimportant the 1s and 2s are. Because if I want to redo this, and I'm just going to do it in the middle of the screen, I could have subtracted the other way. What I did in this case is I took this negative 2 and I subtracted negative 7 and put it on the top. And then I took this 5 and I subtracted 3 and I put it on the bottom. What if I did it the other way around? What if on the top I did 7 minus negative 2, and on the bottom I did 3 minus 5. Then what I would get on the top of this would be positive 9. On the bottom I would get negative 2, but that's the same as negative 9 over 2. And I guess what I'm telling you is it doesn't matter which way you subtract as long as you are consistent. So what I did here in the part that I've left for you to see is I took the second y coordinate and subtracted the first on the top. So then I have to take the second x coordinate and subtract the first on the bottom. If you're following along with that, this becomes pretty easy. Our slope here will be 2 minus negative 6 over 5 minus negative 1. Like anything else that we've been dealing with lately, you need to be very careful about what you do with your negatives and make sure that you have them written in properly. 2 minus negative 6 is on the top, and that gives us 8. On the bottom, we have 5 minus negative 1, which is 6. This reduces down to 4/3. So the slope of this line is 4 over 3. Do the next one. I tend to just always subtract second minus first. So it's negative 6 minus negative 4 over negative 5 minus negative 3. And after a while, you're not going to need to write those arcs and arrows. I'm just indicating that we're always subtracting in the same direction. 6 minus negative 4 is negative 2. Negative 5 minus negative 3 happens to be negative 2 as well. So the slope of this is 1 because negative 2 over negative 2 is 1. Number 2, one point on a line is at 2, 5, and the slope is negative 2/3. What are 4 other points? So I'm just going to pull out a point here and call it 2, 5. Over here, I'm going to put what I'm thinking when I see a slope of negative 2/3. What that means is I go to the right 2 units, pardon me, I go to the right 3 units because the run is 3, and then from there I go 2 units down. Well, listen, if I move a point 3 units to the right, the x-coordinate is going to increase by 3. If I go 3 to the right and 2 down, it takes me about here. But if I went 3 to the right, this new x-coordinate is the old x-coordinate plus the 3. It becomes 5 because I've moved it 3 to the right. And if I then move it 2 down, the y-coordinate is going to lose 2. So this will become 5, 3. Now, I'm not going to continue to draw it in a staircase fashion. I'm just going to say that if I continue to take 3 and add it to the x-coordinate, let's see, that will give us 8. and I take 2 away from the y coordinate, that gives me 1. There's another point. If I add 3 to the x coordinate, that makes it 11. And I take 2 away from the y coordinate, that takes me to -1. So I'm continuing to apply this rule of adding 3 to x and taking 2 away from y because of this diagram. So from 11, -1, I add 3 to 11 and get 14. I take 2 away from -1 and get -3. So there are 4 other points. Number 3, determine the slope of the left side of the roof truss shown. Well, you need a triangle. I've drawn the triangle now. I can see the rise is 10 because the height of this roof truss is 10. And the run is 24 because that roof truss is symmetrical. I guess it doesn't say it's symmetrical, but we assume it is. This is really almost embarrassingly simple, this question, when you look at it in the right way. The slope is going to be 10 over 24, which reduces down to 5 over 12. We have one more example. This time we're asked to draw a line. This almost goes full circle back to the warm-up at the beginning, except we're asked to draw a line with a particular slope passing through a particular point. Well, we can plot -9, 7. That's like taking candy from a baby. X is -9, y is 7. If the slope is -8/5, you should know that from there we go 5 to the right and 8 down. -8 is on the top, it's the rise, which means we go 8 down, and the run is always positive, which is the bottom number, so you get -8 over 5. Boom, there's your line, and we're done the lesson. Maybe one of the biggest things, one of the most important things about this lesson, and there's some practice problems, is being able to use this formula to find the slope of a line. And this is going to be important for the upcoming lessons. After this lesson, we have 3 more to go, where we're going to be looking at finding equations of lines. And one of the prerequisite skills you need is you have to be able to find the slope of the line before you can find the equation of the line. Anyway, it's a quick and dirty lesson. There's not much to it. Hopefully that made sense. Get to work on the practice, and the next videos will be up shortly. Hope to see you soon.